Okay, so I left my tablet at school where I normally write on things. So I've just scanned in the written solutions to the 3132 quiz, and I'm just going to talk through them with you. We briefly talked through these in class on Friday, but was just going to post these again if you didn't have time to see all that now that you've probably had a chance to work them yourself. So the first question was just asking, is there a clear explanatory and response variable? And we said yes, that obviously we would expect the car weight would be the thing that explains the gas mileage. And so the car weight also is on the x-axis, which is always your explanatory variable. And fuel efficiency, or miles per gallon, is on the y-axis, and that's always your response variable. It shows a negative association because as weight increases, the miles per gallon of the car decreases. I didn't add in there why this makes sense, but we know that the heavier the vehicle, the more gas it burns to run it typically, so we would expect it to have a negative association. And then I just said the form is always dealing with the shape. Once we get into R in section 3.2, then R always deals with linear. But in this case, they're asking what is the form, and it is a fairly linear association with the exception of the outlier. The correlation we know has to be negative, so we know it has to be one of the first two. It's very easy to just jump to conclusions and pick the negative 0.9, but you have to take into consideration the outlier that's going to greatly affect R, because R is non-resistant, and so therefore that one outlier greatly affects the strength of the correlation, so it would be a negative 0.6. The unusual point is about 3,000 pounds. The car weight is about 3,000 pounds, and the fuel efficiency is about 50 miles per gallon. And the reason it's unusual is it gets very good gas mileage for such a weight. So most cars its weight have a much lower gas mileage. What effect would removing the unusual point have on the correlation? Well, it would become stronger and closer to -1. So it's a good idea to talk about the strength of it, how it would change, and then also the value of the correlation as well. So right now our correlation, our slope, if we calculated this line, would have to be kind of it would be much weaker. And so if I took away this point, now all of a sudden it's gone and all of the points are much closer, so it now would be closer to like a negative 0.9, so it would be much closer to -1. If we converted the weights to tons, okay, the correlation would not change, because we can convert units all day long. As long as you do it to every one of the car weights, it's not going to affect how they're related, because it's still going to be the same relationship of the x values to the y values. As long as whatever change you make to all the x's, or whatever change you make to all the y's, then the unit conversion is not going to change. The value of r will stay the same. Alright, so for 3.2, gotta watch my time. Alright, so for 3.2, the first question is interpret the slope of the least squares line. So they've given us the equation, predicted y. In this case, y is number of property crimes, so I would have actually written a hat over the word crimes. So predicted crimes is equal to -112.58 plus 21.83 times x. In this case, I would have put in parentheses the enrollment in thousands. So basically, my slope is 21.83. I write this as change in y over change in x. So change in y is 21.83 y, which is crimes, over x, which is 1 enrollment. And then I know that this is in terms of thousands. So my statement is simply, as the enrollment increases by 1,000, the number of crimes increases by 21.83. And the reason I know it increases is because 21.83 is positive. So therefore the number of crimes is going to increase 21.83 crimes on average for every time the enrollment increases by 1,000. How many crimes would you predict? So we're going right back to this prediction equation that they gave me up above. And I should have written predicted crimes and enrollment, but instead of enrollment, they ask us to do it for a specific enrollment of 14,000, but the equation was already in thousands, so there's no reason to put 14,000. It's just 14. Plug that in, and my predicted y, or my predicted crimes, would be 193.04 crimes for a university with 14,000 students. Find the residual. So a residual is actually observed minus predicted. So the reason I know the observed is 14,138 is that was the actual observed data value for a specific university. For 14,000 students, it had 138 crimes. So that was my observed value. The predicted is exactly what I calculated up there for that equation. So when I plugged in 14, my predicted number of crimes was 193.04. Residual is always the observed minus the predicted, the y minus y hat, and so my residual is negative 55.04. The fact that it was a negative residual means that when I took my observed and subtracted it from the predicted, my observed fell below the prediction line, so therefore the explanation of this is that the prediction equation overpredicted the number of crimes. 4 years may look totally different. I kind of did this by hand, but I was just doing very small standard deviations here, or z's here, so when you did it on the calculator it might have looked a whole lot different, but they ask you just to graph the enrollment and then the residuals for each one, and so you could have done the residual plot on the calculator. Would the slope of a regression line change if the point 26601 were removed from the data set, and if so, in what direction? Well, here's 26601, and right now this line is probably being pulled upward to try to kind of even out the distances between all these points. If I take this point completely away, then more than likely it's going to kind of tilt downward, and so it's going to be a little less steep. So yes, the slope would get affected. It's not going to be as steep, so therefore the slope value would decrease in value. It would still be positive though, but it just wouldn't be as steep and it would be a smaller slope. The value of r squared for this data, interpret the value. So this is that fill in the blank for the percent of variation, and this is what I worked through on Friday, trying to explain why this accounts for the percent of variation. And this was back to those slides where we did the prediction, the sum of the least squares for a line using y bar, and then we did the sum of the least squares for the prediction line, and then we calculated the percent of increase or decrease. And you don't have to do this, but that was just what we did to try to explain why this does answer this. But 80.1% of the variation in the proportion of crimes can be explained by the linear equation between enrollment and the number of crimes. So it's basically 80% of the variation in y can be explained by the linear equation between x and y. So that's just that fill in the blank, and y was the number of crimes. I don't know why I have proportion of crimes. It should just, property crimes. I was thinking that was proportion. Variation in property crimes can be explained by the linear equation between the enrollment of students and the number of crimes. Is the least given squares, if the given least squares regression line a good model? So they actually ask you to use your answers above, but I used several different things. First of all, I knew r squared was 0.801, and therefore I knew that r was 0.895 just by taking the square root of 0.801. Well, r 0.895 is definitely a pretty good strong correlation, and that implies linear relationship. And r squared, 80.1% of the variation be explained by this linear model, is pretty high as well. Considering 100% would be the best. And then I also went back and just said the scatter plot shows a positive linear strong pattern. And then I just said what in words what I just said to you. The correlation coefficient is 0.895, which is strong, percent of variation, and therefore it is. And also the residual plot at the top was fairly random, and that also indicates it's a good linear model. So I just used everything I could, r squared, residual plot, and then also the outline, the shape of the scatter plot as well. So that is it for this little worksheet that you needed to finish for the weekend for me, and then I'll also am posting another one as well on the AP review for normal distributions.